So in this session, let's try to understand how to bring in an AI based solution for a real world problem. So this is the pic of a traffic light which is available in most of the junctions. So the duty is to make any one of these lights to glow so as to indicate the travelers about the action that they need to take. The red light will glow asking the people to stop, followed by green lights, and then sometimes the orange light will glow, and it will go on in a sequence which is predefined inside the system. Now assume that an ambulance is passing by. So at that time, irrespective of whatever lights that has been grown, all other three sides other than the one where the ambulance is coming has to be stopped. For all the three other sides, the red lights has to glow, and only the path where the ambulance needs to travel has to be given the green light, right? So that is one intelligent activity that we want from an automatic traffic light. In contrast to the regular schedule that it follows, we need to have some change. So this change has to happen based on certain conditions that it is going to observe from the environment. So this traffic signal light, which is actually looking or watching keenly into the environment in which it is embedded. This watching is what we call as perception. We are perceiving this machine, this intelligent machine, like how a human being, like the traffic policeman is standing at the signal trying to watch what is happening. This intelligent traffic signal has to watch the happenings that are happening around it, which we call it as the environment, and accordingly it has to take the decision. This is what the first term that we need to understand while we move on for an AI based solution. The deployment place, you may assume like that. How to do that? How to bring in that intelligence? See, the human being will automatically work this in the brain without knowingly or unknowingly. Automatically he can just put off the stop points in whichever direction is required and will let the other direction to go, right? So this only through the set of AI algorithm that you are going to write. So this is the algorithm, so which is going to process the input which has been picked up by this traffic signal from the environment. So you are going to give input. So capturing this input is what we call as perception, and this needs to be processed through the AI algorithms that you have done, or you have written as part of the intelligence program or intelligence programming or intelligence computation. Then this actions has to again get reflected back to the environment. I have this intelligent machine looking at the environment, passing back the results back to the environment. But how do we do that? It is through the set of AI algorithm. Here in technical terms we call it as agents, right? In particular we call it as AI agents, artificial intelligence agents. You have this intelligent device which is working on this environment, and we need to take in the input from the environment using the perception. This perception is a very important activity of AI and cognition. Always you should have a keen interest over the environment. That's how the human beings are evolving, right? And how do? We have sensors fitted in, right? These sensors are the hardware devices. It could be the hardware devices, or it could be the software agents that you are writing as part of your coding, which is going to keenly observe what is happening around. And then the processing will happen through the AI agents which you are going to write. Finally, the actions or again has to be thrown back to the environment, right? How do you give the actions? Again, let's say for example you are calling a robotic waiter. So the waiter has to reach you. He is able to hear you through the senses, which is the audio speakers which is fitted into them. They are able to hear and they have understood your voice that you are calling them. Now how to reach you? It has to move the legs to reach you. So what are those legs are called? We call it as actuators, right? In this case the actuators are nothing but the switch on and switch off lights of each of the traffic signal available on the 4 directions. Now in this session we'll continue with understanding the different kind of environment that you will end up with. So we have varieties. The list is not exhaustive. So depending on the observability, right? How far can you observe the environment? We have, and depending on the number of agents you have in the environment, you have, depending on the finiteness of the actions, dependency, change, and then frequency of change, we have varieties. Let us look at one by one. So depending on the observability of the environment, we have two. One is partially observable and another one is fully observable. Then these are the varieties that are available. Let us try to understand one by one. Looking at fully observable and partially observable, you could see on screen the figure of a tic-tac-toe game, right? So let's say this heartines are placed by the human users and this cross mark is placed by the robotic game partner who is going to play ahead of you, right? So this is a fully observable environment, meaning that the entire environment is in our control. We can understand, right? So when I place a heartine again here, okay, I can win the game. Or if I'm placing here again, you can win the game. So accordingly, the other will also play. So the entire environment has only predefined set of actions, and I know that this is the environment in which I'm going to work in. I know all the set of rules and regulation. That's what we call it as fully observable environment. In contrast to this, look at the autonomous vehicle, right? So this is the perfect example for an AI based solution. Like a human who is going to drive on road, we want the machine to run, right? So is it fully observable? Do you know what kind of actions will come in this environment? So the action that you need to do is to apply acceleration, brake, the directional movement, everything. But this is partially observable. You can look at, and your cameras can look just 10 meters ahead, 50 meters ahead, 100 meters ahead, that's all. And only till that point your actions will be perfect, and then after that you have to again update yourself in order to arrive it. So such kind of situation we call it as partially observable one. Then looking at the number of agents, okay, which is going to operate on your environment, it could either be single. Let's say this person is taking their tennis training, okay, as solo in a single court, okay, so he will be just working towards the ball, that's it, okay. So the actions are aiming only with this single agent. So single agent or the one where you will have only one. For example, you have some kind of this card games, okay, where your concentration will only be on achieving that particular target, not anything else. So that kind we call it as single agents. In contrast to that, look at multiple people who are playing, okay, either the football or the tennis or the basketball, where you have multiple agents. See, the result or the action that you are going to end up with is the combination of multiple agents action. So that is multiple agents. So this is agent 1, this is agent 2, and this is agent 3. All together will contribute to the decision making. Then we have depending on the finiteness of the activity, okay. So in theory of computation we would have studied about NFA, DFA, deterministic, finite, automata, non-determinism. So deterministic is where from the state when I apply this, I can definitely say that I can reach to only this state, okay. So when it is determined or finite, we say it is deterministic. So how much ever, see, if I do this for this time, if I do the same activity after 10 minutes, I'll get the same result, okay. So let's say I'm going to purchase an LIC policy, okay. If I purchase it now, if I purchase it after 1 hour, okay, if the inputs are same, I'm going to get the same output. So that we call it as deterministic. Stochastic, in contrast to that, it will be a kind of dynamism will be included in that. So the activities will be random, okay. Look at the stock market, okay. So if I try to buy a stock this point of time when it is 100 rupees, okay, so when I refrain myself from buying for around 5 minutes or 1 minute at least, okay. So either the stock price may go down or stock price may come up, it depends, okay. So that kind of dynamism which is parallelly going with respect to time also, and also, okay, the availability of stock is also a matter, okay. That is what we call as the randomness, stochastic activity. So whether the activities are finite or is it going to be random. And a simple example is, okay, so you have the chess game wherein the activities are always finite, right? So when I move my horse or when I move my soldier, okay, to the next point, the activities will be very finite, and even though you have an exhaustive list, okay, depending on the size of the board or the size or the, but anyway, okay, the activities will definitely be finite. In contrast to that, look at this football game. Okay, nowadays you could see your kids or your friends playing this football game in your mobile. Okay, the activities are random. You can never say that always this ball will go only towards the straight or to the left. Okay, it is completely random. It depends on multiple things. Again, it is only coding, but the end user will definitely won't have the feeling that it is coded. Okay, it looks like a real-time activity, so that we call it as stochastic. And the next environmental type goes on based on the dependency of activity. Episodic is where your activity depends only on the current situation. Okay, so for example, you have a lot of chatbots like Alexa, Cortana, so many other things, right? Whichever site you go to any banking sites, definitely a pop-up comes in requesting or asking you whether you need any help or not. So that we call it as bot. See, what will it do? When you ask a question, it will answer, that's it. When you ask it for the next time, again it will answer. There won't be any relevancy between the previous question, and it will not keep up. Okay, the answers for 10 questions and the relationship between one and the other, it will definitely not keep up. So that's what is episodic. Okay, it's on the particular episode of web series. Okay, in contrast to that, you have sequential, wherein the actions depend on similar some n previous actions. Okay, for example, so this that is the tennis which is being played by the robot. Actually it is based on the decision of where to stand and how fast I have to throw depends on my previous actions. Okay, so earlier the ball would have come on the right hand corner, so it might be standing there, and the fastness that the other person or the competent has throwing on it might be a bit low, so it would have reduced the fast. Okay, the actions, if it is going to be dependent on our previous steps, then you can say it is sequential. Then moving on to the change that you feel in the environment. The environment can either be static or it could be dynamic. Okay, static, this in a way is slightly related to deterministic or stochastic. So you observe, most of you would have known this is a cleaning robot. Okay, very famous cleaning robot which is available. Generally, if you use this cleaning robot early in the morning where nobody has woken up, and then if the hall is empty, then it will follow a certain rule. It will start from the one end corner, then it will move, and it know where the parts are, and it will be embedded onto that. Okay, so it will not definitely get confused. So that kind of environment will call it as static. So programming for static environment, of course, it is comparatively easy. But let's say you have a dynamic environment where you are the owner of this house is actually leading with multiple cats and dogs. Many domestic animals are there, so they will run in between. So one cat is coming and assume another cat is coming, somebody else is trying to enter the room. So what will this robo will do? Okay, this cleaning room, it has to, in addition to the way that it has to travel, it has to look at, okay, the different obstacles that is coming in place, and accordingly it has to take the turns. So that kind of environments are what we call as dynamic environments. So finally, last but not least, depending on the frequency of change, okay, how far your environment is going to change. Is it going to be a static one which you observe today morning? Is it going to be the same till the evening? That is discrete. Or if it is continuously changing, we call it as continuous environment. Okay, you look at the chess game. Okay, this is a discrete environment because 10 times you open and close, the same environment is going to be there. You will not get only if you update the game, yes, there will be a change in the scenario, otherwise it looks like the same. The other case is continuous, where you look at this environment, see you are driving on road, the road will not look like the same. It may look like the same for the next 50 meters, but definitely there will be a change. So that's what we call it as continuous. And these are the different environmental types that you need to understand, and we need to fix up before going for agent design. Okay, so this environment understanding is very important given a real world problem. Okay, so the type of environment, the mapping has to be understood. Okay, has to be identified, and finally the environment types has to be set. So catch you up in agent design or agent function design in the next video. Thank you.